Hello everybody, I am Mr. Philip J. Zhao, a first-year college student under the program of Bachelor of Secondary Education, major in Science. And for today's video, let's learn how to draw a Lewis dot structure. We've learned about how ions come together to form ionic compounds. But much more interesting is the way atoms form networks of covalent bonds. In order to talk about this, we're going to have to learn how to draw a Lewis dot structures. When we draw this, we will represent atoms by its chemical symbol. Here's carbon. We then draw the atom's valence electrons, dots around the atoms. Carbon is 1s2, 2s2, and 2p2. So that's 4 electrons in the outermost shell, which you can also tell by counting over from the left. For carbon and other small atoms, we assume that there are 4 coordination sites that can accommodate electrons or bonds, because this is how carbon can fill its octet, or its outermost shell. When we draw the valence electrons, we put one in its coordination sites first before pairing them up. So carbon will look like this, not like this. Elements in the same group will have similar looking and Lewis dot symbol because they have the same number of valence electrons. Now to draw a Lewis dot structure for a molecule, just draw each atom with all of its valence electrons. Unpaired electrons from 2 different atoms can come together to form equivalent bonds. When that happens, instead of 2 dots, we make a line. This is a covalent bond which always contains 2 electrons. For our purposes here, we assume that the electron need to be paired, so a good Lewis dot structure will have all the electrons either inside the covalent bonds or in lone pairs. So the number of valence electrons an atom has dictates how many bonds it tends to form. Carbon likes to mix 4 bonds. Nitrogen, with 5 valence electrons, likes to have 3 bonds and 1 lone pairs. Oxygen likes to have 2 bonds and 2 lone pairs. And fluorine likes to have 1 bond and 3 lone pairs. When 2 atoms have 1 covalent bonds between them, we call that a sigma bond. But atoms can have double or even triple bonds. Look at carbon dioxide. After we make a sigma bonds between the atoms, there are still unpaired electrons. If adjacent electrons each have unpaired electrons, they can become another covalent bond. The second covalent bond in a double bond is called a pi bond. The second and third bonds in a triple bonds were also called a pi bonds. Single covalent bonds are the longest, double bonds are a little shorter, triple bonds is shorter still. More on these later. Sometimes an atom in the Lewis dot structures will have a formal charge. This happens if the number of electrons an atom is contributing to a Lewis dot structure is different from its typical valence. Nitrogen has 5 valence electrons, so in ammonia, where it contributes those 5, 1 pair covalent bond plus 1 lone pair, it would be a neutral nitrogen atom. For the ammonium ion, nitrogen is now contributing 4 electrons to a Lewis dot structure, 1 per bond, that is less than its typical valence, and 1 fewer negatively charged particles means the nitrogen will have a formal positive charge. That makes this a polyatomic ion. These elements want to fill their octet by having 8 electrons around them, filling n is equal to shell. Hydrogen is very small, so that only need 2 to fill the n is equal to 1 shell. And larger atoms like phosphorus and sulfur can make 5 or 6 covalent bonds. Just draw valence electrons and start combining unpaired one. Let's check comprehension. Thanks for watching, guys. I hope that you have learned about how to write a Lewis dot structure.